So let's look at this problem. Find the derivative of y equals square root of x times x to the fifth plus 2. It's going to help us when we do these kinds of derivative problems that involve functions, if at all possible, to rewrite things in terms of power function. So I can rewrite square root of x as x to the 1/2. After I do that, then I can rewrite this as x to the 1/2 times x to the fifth plus 2. And now I can distribute this x to the 1/2 through, so that this becomes y equals x to the 1/2 times x to the 5 plus 2 times x to the 1/2. Now I can combine these exponents. So I will have y equals x to the 1/2 plus 5 plus 2 times x to the 1/2. If I get 5 and I add 1/2 to it, that's going to simplify to be y equals x to the 11/2 plus 2 times x to the 1/2. Notice all of this was just algebra. I haven't yet done anything to start taking the derivative. Let me be clear that this is an 11. Now, if I want to find dy dx, I can just apply basic power rule. This will be 11/2 x to the 11/2 minus 1 plus 2 times 1/2 x to the 1/2 minus 1. And now it's worth simplifying this just a little bit. I can do 11/2 minus 1. That will be equal to 11/2 minus 2 over 2, which will be 9/2. And so I can rewrite this as 9/2. Similarly, 1/2 minus 1 will be 1/2 minus 2 over 2, which will be negative 1/2. So if I go to simplify this expression, what I end up with is dy dx is equal to 11/2 times x to the 9/2 plus the 2 and the 1/2 cancel and just leave me with 1. And so I have x to the negative 1/2. You might be able to do more with this. If you'd like to simplify it a different way, that's fine. But for our purposes, now, something to be careful about is putting this in the right way. So it's good to have these parentheses that are careful delineators of exactly what you're typing in. Usually when you have an expression that involves powers, if you have a fraction in a power, it can be good to put the entire thing in parentheses.